In previous lectures, we discussed a type of function that's great for representing waves because it's periodic. This is the sinusoidal class of functions. The cosine curve above is a type of sinusoidal equation. Typically, the cosine curve is used to represent the wave equation, which looks something like this. We have x, which is the quantity that's oscillating, such as pressure, is equal to the amplitude, which hopefully you remember is the distance from the peak or the trough to the equilibrium point. Represent this as A, times cosine of omega t. Omega here is the angular frequency, which is a special type of quantity that represents the number of oscillations per time. The angular frequency is equal to 2 pi, which is the distance in radians around a circle, divided by the period, t. The period is the amount of time required for a single oscillatory cycle to occur, so that is the amount of time for one wavelength to pass. This is a single wavelength, lambda. That means that this distance along the t-axis, this time, is the period. The wave equation relates the quantity that's oscillating to the time that has passed. This is for a particular point in space. This means that if we know something about the wave, we know its angular frequency and we know its amplitude, and we're given a point in space, then we can determine what the quantity will be at that given time. Sometimes a third quantity is involved in this equation, which is the phase angle or the phase lag. This phase angle indicates what would happen if you shifted t equals 0 to be here. This means that your amplitude, which would be here, isn't the initial position or isn't the initial value of the quantity we're considering. In this particular case, I've drawn the new x-axis such that the initial position is at equilibrium. However, I could have drawn it here or anywhere else along this line. To represent this mathematically, we must add this third quantity, the phase angle, here. The phase angle is measured in radians. So let's try an example. What if we have a wave with an amplitude of 2 atmospheres? So this is obviously a sound wave since we're dealing with pressure. I'll also say that it has an angular frequency of 3 oscillations per second. I'll also tell you that the pressure at time 0 is 2 atmospheres. How would you write the wave equation for this? So let's give it a go. We'll say pressure is our oscillating quantity, is equal to the amplitude, which is 2 atmospheres, times cosine of omega t. So we have 3t plus the phase angle. In this case, the amplitude is our initial point, so we don't have to worry about the phase angle because the phase angle is just equal to 0. So this is our wave equation.